Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So the topic that we will discuss today it is the hydration energy. Basically, the word hydration it is denoting the total hydration of the different ions. Hydration means we are going to add the water. When we just add the water, then there is a release of energy. That release of energy is basically known as the hydration energy. Now, when and where this heat of energy or hydration energy is going to be released, so the amount of heat that is evolved or released when 1 mole of gaseous ions dissolve in water and it forms an infinitely dilute solution. So, we just do this process for the preparation of dilute solutions. As these dilute solutions are formed and they are infinitely diluted. It means we don't know their finite point that how much they are diluted. So that's why we have to just add 1 mole of any substance that are gaseous ions and we have to dissolve it in water. In turn, the energy will be released. When in a chemical reaction, the energy is going to be released, this process will be exothermic. The word exo mean there is the exit of energy or the energy will be evolved. And we always show that energy with the negative charge or negative sign because here the energy is evolving from the process. On the other hand, the hydration energy it can be denoted by delta, where the delta is showing the change in energy and the small h is showing the hydration energy. As this process is highly exothermic, so it releases a high amount of energy as a result of the process. Let's have an example for the hydration energy. For example, we have just added the hydrogen ions, and these hydrogen ions are present in the gas phase and we just add it in the water. We just gain the product. This is known as the hydronium ion. In the process, we just gain the energy which is minus 1075 kilojoule per mole. So here the minus sign is showing this process is exothermic and the heat is liberated as a result of this process. So, on the other hand, we have also many examples like if we are going to dissolve the lithium, then the energy released it will be almost minus 499 kilojoule per mole. If we're going to add the sodium, then the amount of energy will be minus 390 kilojoule per mole. And if we are going to add the potassium ions, then minus 305 kilojoule per mole of energy will be released. So these are some examples when we just add up the lithium, sodium and potassium ions as the energy is released because the water molecules just surround these ions. So this energy is known as hydration energy. Why it is known as hydration energy? Because the word hydra means simple water and ration means is going to surround. So when the water molecules surround the ions or the gaseous ion, the energy will be released. This is known as the hydration energy. Then we have the trend of hydration energy in the periodic table. When we move from top to bottom in the group, the hydration energy decreases. Now, what is the reason is the ions get larger. For example, we have a lithium ion. It by losing one electron from the valence shell, its ion will be this lithium. Then we have sodium, 2 electrons in the first shell and the 8 electrons in the second shell. This is for sodium. Then we have potassium, 2 electrons in the first shell, then 8 electrons in the second shell, and again third shell contain 8 electrons. So this is for potassium. So when we move from top to bottom, you can see that the size of these ions increases and the hydration energy depends upon the mass to charge ratio, or we can say that it also depends upon size to charge ratio. When the size of an atom increases, then the charge density also started to expand. When it started to expand, and there is a direct relation between hydration energy and size to charge ratio. Direct relation size to charge ratio. As we move down in the group, the size of ions increases. When their size is increases, then the size ratio decreases from top to bottom. That is the ratio of size to charge. So that's why the hydration energy also decreases from top to bottom. On the other hand, when we move from left to right in the period, we can see that the hydration energy increases because the ions gets higher charge but smaller size. So the charge density increases. When the charge density increases on the ions, in turn their hydration energy also increases. So when we move from left to right, their hydration energy increases in a simple way. We can have example for this. The hydration energy for lithium, we have it is almost minus 499 kilojoule per mole. And then we have magnesium. Its hydration energy is minus 1891. And then we have for aluminium. Its hydration energy is minus 4613 kilojoule per mole. So moving from left to right, their hydration energy increases because their density increases, which is the ratio of size to charge ratio. So this was a simple overview about the hydration energy of the elements. So you just keep it in mind that from top to bottom it decreases and from left to right it increases. I hope you guys understand, and if you have any queries you may ask me about that. And the next topic that we will discuss it is halides. For that time you guys have a good day and keep learning.